All right, folks, it's Bass Action back in action here. In this video, I'm going to talk through the examples in the circles warm-up. Again, I've got everything all worked out, so if you need, you can just pause this and write it down, or fast forward to whichever example it is that you need to look at. All right, examples 1 and 2 here. These are really important examples to draw a sketch. Although there are some people who can do these problems without a sketch, I would really encourage most of you guys to draw a sketch because I think it's going to make it a lot easier for you. On example 1, we're trying to write the equation of a circle. Now remember, that means that we're going to have two sets of parentheses. They're both going to be squared. We're going to add them together and we're going to get our radius. So inside each of these, the binomials will simply be the center. So we can actually start our answer without a lot of work here because it tells us that our center is supposed to be at 1, -2. So we can immediately drop in the -1 and the +2 there. Now, what we need to figure out, though, is what this radius should be over here, or in fact the radius squared in the form of the equation. That's where our picture is going to come in handy. So when we're making these sketches, don't worry about them being to scale. Just make sure that your points and everything are generally in the proper quadrants. So if I sketch in my center at this point 1, -2, and it tells us that our circle is going to be tangent to the line x equals -5, which means it's going to be a vertical line. So you can see I've just dropped that in right there. It's just a little dotted line there. So we're looking for a circle that's going to look like this. So it's going to generally look like this. I don't need to draw the circle, but it's going to look like this. So the radius, if it's going to be tangent to that line, that radius is going to just be the distance here from the center to that line. And we can just count it. From a -5 to a 1 is going to be a radius of 6, and then I just square it. On the next one, I want to find all the points that are on the y-axis, remembering that points on the y-axis will have a 0x value, and it tells their distance is going to be 3^7 from this point, -2,5. So I'm going to start putting this together. I've got the point -2,5. I need the points that are going to be on the y-axis, and what we can actually visualize here is a circle. So if this is my center and I visualize a circle here, okay, my circle would intersect that y-axis twice. So what I need to know then, I know that the distance from the point to the point on the y-axis is this 3^7, and if I can write the equation for this circle, center, radius, then I could just find the y-intercepts. So that you can see that's what I did here. -2, 5, there's my center. Then my radius squared is going to be a 63. So 3^7 times 3^7 gives me a 63. And now I want to find the y-intercepts. And I've got two y-intercepts here. So I'm going to let x equal 0. This goes back to the very beginning of the videos that we were doing. And I just let x equal 0, subtract that, take the square root of each side. Don't forget the plus or minus you're going to get here. That's how we're going to get these 2 points. And there are the values. The next one, we're going to find our intercepts, and we're going to write it in the equation in standard form. And the first thing that I want you to notice on this equation here is that every term in the equation that I've given you divides by 3. So right away, I'm going to reduce this. Now, if these didn't all reduce by 3 and it was going to introduce a fraction in there, I might not go ahead and do this step. But since everything reduces, I'm going to go ahead and start my problem this way. Now, I'm going to group the x's right here, and I'm going to group the y's right here. If there was a constant, I would have moved it over, okay? Then I'm going to insert the blanks so that I can complete the square on the x's. 6 divided by 2 squared is 9. So I'm going to put a 9 on the other side too. Then I'm going to insert a blank for completing the square for the y's. 10 divided by 2 squared is 25. Balance it. Then I can write the binomial, the x plus 3 quantity squared, the other binomial squared, and my 34. Now I have the equation for my circle. So I can plot my center. Since a square root of 34 is going to be the radius, and that's a little bit less than the square root of 36, or in other words, a little less than 6, I'm just going to approximate that radius to get the north, south, east, west. Now, when I do this little sketch, I can see I need 2 y-intercepts and I need 2 x-intercepts. Now, I can't tell this, does it exactly go through 0, 0? I'm not 100% sure, but my algebra will answer that. Then I can just go through finding the y-intercepts and the x-intercepts by letting the x and y equal 0, similar to what we did in the very beginning of the semester. If you're struggling with this, you can go back and look at the finding x and y-intercepts video that we did for algebra skills, and that'll get us to our intercepts, and sure enough it verifies that yeah, it does in fact cross through 0, 0. Now, keep in mind, these intercepts that you calculate here should at least look reasonable. So even though your sketch is still a sketch, it should look reasonable for the graph that you have created. Then the last thing that we've got in this warm-up is similar to what we did on the previous warm-up for lines. We're going to look at which of these equations might be for this graph. So again, take a look at your graph and think about things that you would know would be true. I can tell from this graph that the center needs to be on the y-axis, or on the x-axis, I'm sorry, it needs to be on the x-axis. So the x-coordinate of my center needs to be a negative value. The y-coordinate of my center needs to be 0. And my graph should not cross the y-axis. So there should be no y-intercept. So as I go through these, I can start to analyze it. When I look at this first one, I can see that the x-coordinate of my center is a positive number, so there's no way this one could work. On this one, the x-coordinate for the center is negative, the y-coordinate is 0, and I can go ahead and if I checked for y-intercepts, what I would find if I let x equal 0, I'm going to solve this, and that's going to give me a 4. We could even write this out. If I wrote this out, I would end up with 4 plus y squared equals 3. And if I solved that, I would sure enough get an imaginary number for the y-intercept, and that would give me no y-intercepts. You could also graph it, recognizing that if your center is at a -2, 0, and the radius is the square root of 3, it's also not going to make it to the y-axis. On the next one, my center is 0, 2, so that would mean that the center would be up here, so that doesn't work. On this one, my center checks off, but the y-intercept, if I quick calculate that, is actually at 0, 0, so that one gets thrown out. On the next one, what I did here is I actually found I covered up the x's and the y's to find the intercepts. So if I found my y-intercept, letting my x's be 0, so this term drops out and this term drops out, what I see is that I don't have a y-intercept because this is the y squared is a -16. So that's okay. But if I actually go to put this in my standard form, my center is at a -5, 0, so I get an x-coordinate for the that's negative for the center, and the y-coordinate is 0, just like I wanted, so this one works. The next one, I did a quick just finding the y-intercepts and found that I had y-intercepts, so it failed. The next one, again, I just checked the y-intercepts in the center. Again, I could quick put that into a standard form, just reasonably getting it close, and so that one checks out. And the next one, I get y-intercepts, so it fails. All right, and if you've got more questions, I certainly can answer those in class as well.